Okay, it is now recording.
All right, welcome to SIG Auth for March 4th. Sorry about the snafu there. So to get started, we have an announcement that the secret store CSI driver has now been migrated to Kubernetes SIGs. So that's now an official SIG Auth project.
I was going to ask, do we have anything else in Kubernetes SIGs that's like official for us?
For SIG Auth?
Yeah.
Not that I know of offhand.
Okay. Well, go us. We have one thing. Yay.
Is Christy on the call?
Yes, I'm here.
Yeah, do you want to take it away for the demo?
Yes, but apparently I cannot start the screen share while the other participant is sharing.
Oh, got it. All right, go for it.
Okay, so hi everybody, and thanks for receiving me in SIG Auth. So my name is Christian Klein. I'm working at TLS, a small consultancy company in the cloud native space located in northern Sweden. And we're trying to specialize in compliance. And I myself have been a researcher, teacher, and consultant in cloud computing for probably since the term was, almost since the term was coined. So I just wanted to go very quickly about what is compliance and why exactly this project is so important for us. So there are very many industries that are under heavy regulations, such as financial technology and medical technology. And in order for these to gain the public trust to work with financial information and to work with personal information, they have to adhere to a certain set of regulations. And this is just not just something, a paper stack that gets stashed into a desk and that's it. But on the contrary, they're being audited regularly. And if the auditor determines that the company is compliant, then they can continue operating. Otherwise, if they determine that they're not compliant, then basically they have to close shop, and well, all the developers there need to brush up their CV. So now there are various regulations, and there is one of them in particular when you're talking about defense contracts that is very much about physical security. So in that kind of regulations, you might hear about weird stuff such as network cables being physically visible and not hidden inside the walls, so that they can at any time be checked whether they have been tampered with. So it should come as no surprise that they really like to be able to point at the physical object in which all the credentials are being stored. And this is commonly done via hardware security module. So my favorite one is the YubiKey that is, let's say, a bit more targeted at developers. But you have, of course, also higher end HSMs such as Luna Electronic Fund or Gemalto or Thales. There are all kind of providers for that. And the idea is that once the private key is uploaded to HSM, it cannot be extracted. It's usually also protected behind a pin so that you cannot, and if you don't know the pin, after 3 attempts, you're being locked out. And often they also have certain features such as the number of signatures that have been for which the private key has been used or counted and timestamped and so on. So all in all, your laptop has no credentials and it communicates with the HSM using a standard such as the PKCS11. Certainly the person who has invented standards hasn't thought about pronounceability. Anyway, and then your laptop is delegating all operations such as signing, encryption, and decryption to your HSM. So now, typically HSMs would be used, for example, to generate one-time passwords. We have quite a lot of customers that use them for SSH keys and PGP keys, and they can equally well be used for TLS client authentication. Unfortunately, until recently, there has been no support for TLS client authentication using HSMs in kube control, until, of course, today. So let me show you overall how this contribution could be made useful. So I envision 2 scenarios, 2 user stories. Let's call whoever controls the client certificate authority of the cluster, the Kubernetes administrator. And there are two scenarios. Either that person would create a certificate and a key, and that would be then imported on the HSM. So in this scenario, you could do what is often called an off-key backup of your certificate and key. The other scenario would be that you generated the certificate on the HSM itself. So there will be no way of you to backing up that private key. And then you would send a certificate sign request to the cluster, to the Kubernetes administrator. And finally, you would import the signed certificate back onto the HSM. Okay, let me try to give you a demo. If I can only figure out how.
It looks like you're sharing a single window. I don't know if you're trying to share a different window.
Yeah, I cannot really find how to unshare this window and share a different, found it, okay. Let me then new share. And then, yeah, now you should be seeing a terminal or something like that, right?
Yep, you got it.
Okay, so now I'm going to do what I like to call a semi-live demo. So let me maybe zoom in a little bit so I can see it easier. So the keystrokes are pre-recorded, but the commands that are happening behind the scenes are real and the output of those commands. So just before this demo, I have started the Minikube cluster. And then if I, for example, look at what the pods are running in this cluster, then, well, you might all recognize the familiar pods that are running in the kube system namespace of a Minikube cluster. However, the problem is, as in with many configurations of kube controls, that the private key is resting on my laptop. And so now, for example, if you would quickly copy paste this thing here, then you could potentially endanger my Minikube cluster and hack into it. And like I said, there are certain environments in which this is an unacceptable risk, and certain regulations that really want you to put credentials on a specific device, on a specific physical device for that. So the way we can improve the situation is, let me not forget to plug my YubiKey in. Okay, so I just plugged my YubiKey in, and I'm going to upload the key onto it. I'm going to then upload also the certificate onto it. So this is more like the use case number one, where the cluster administrator has generated the certificate and the key, and then I upload it on the HSM. So now I can actually wipe the two certificates. And just to show you that this is actually doing what it's intended, indeed, now I can no longer connect to the cluster because I'm lacking the necessary credentials. So now I'm going to use the contribution that I'm about to discuss now. So I implemented a custom authentication provider, PKS 11. Let me show you what is the resulting kube control to discuss it a little bit easier. So basically what I say is that, well, the auth provider is PKCS 11. PKCS 11 implies that I need to have some kind of module that translates the signature and encryption and decryption operations into USB commands for the HSM or into PCI commands for the HSM. This is a module that is very hardware specific and needs to come with the hardware. Also specify the slot ID. So if I have several HSMs, then I can, slot ID is the term in this standard for specifying which HSM I'm addressing. And object ID is the certificate that I want to access in case I have, let's say, several certificates on it. And then in this case, I put the pin in the configurations. In future versions, I plan on making the user type the pin at the terminal if it's not specified in the configuration file. So now if I do kubectl get pods, then ta-da, I even left here a small debugging message just to make clear that this is a slightly different code path than the previous one. And I can see again the Minikube cluster. And then now I'm going to pull out the YubiKey. And if I try to do the same command again, then I'm getting an error with the PKS 11 token not being present anymore. So I thought to also present how it's going under the hood before taking questions. Is that okay?
Yeah, it's fine.
Okay. Do you see now some presentation slides?
Yep.
Okay. So I have also prepared a not so live demo just in case the live demo wouldn't work, but fortunately that was not the case. So the way this works under the hood is that when the user types kubectl get pods, then there is a certain phase during which the transport, the TLS setup is being done. And here I have added some code in order for the TLS configuration to be slightly different. And there I'm calling find key pair against a library called Crypto11. So this is a library that implements the PKCS11 standard in the Go program language. This in turn gets converted into a find objects call against the HSM specific module. So this is basically a C binding a C call against the .so. This gets translated into USB commands to the YubiKey. And then coming back on the path, this returns eventually a TLS certificate object, which includes a custom crypto assigner with a crypto assigner interface that is again implemented by the Crypto11 library. And then when at some point the server, the Kubernetes API asks for the Kubernetes client to prove that indeed it controls the client certificate, then the sign operation is being sent to the Crypto11 library, to the PKCS11 SO module, into USB commands, and then the signature is being propagated back. Now, I have asked a little bit people around on Slack already if this is okay. So I should mention probably that we were contracted by a company to implement this, and one of the main requirements was that we need to implement in a way that is upstreamable. So it seems that it was very important for them that our contribution would be accepted in mainline Kubernetes and not have a separate fork for this. So I have checked initially on Slack what could be the problems with this architecture, and the main issue that was raised was that kubectl requires, I mean, in this particular implementation, kubectl would require CGO. So this is a little bit, one could say by definition, because since the .so is a C library and the standard need mandates to do C calls, then basically you're forcing yourself to compile kubectl with CGO. Now, my understanding is that this is not okay. And so there are two ways of fixing this. Either one could insert some kind of TLS certificate proxy. So in this case, these call find key pair and the sign call would then of course be somehow proxied either via standard input and standard output, or maybe via some gRPC protocol that is running on the locus user host. And then to the left of this blue bar would be one process, the kubectl process, and to the right of it would be a complete different process. Or the other possibility would be to implement some kind of PKCS11 proxy. I haven't found any on the internet, and I feel that implementing a complete one would be quite a lot of work. So I would rather favor this first approach. So now I have some open questions that I would very much appreciate if you could help me answer. So first of all, how important, let me just fly through the questions, and then maybe somebody can moderate the order in which the questions should be answered. So first of all, how important is avoiding CGO and kubectl? I have noticed that there are some issues already open in GitHub, which are, let's say, contesting the position, and especially on macOS, my understanding is that kubectl is compiled with CGO in order for some DNS resolution to work properly. Then I was wondering, assuming that the answer to this question is yes, it's important, then what would be the preferred way of avoiding it? And then also, how generic should the implementation be? I mean, should this interface be generic enough to be consumable by some kind of plugins in the future? Or can this kind of be considered an internal API that is specific to something like the PKS11 authentication plugin? And then depending on what the answer to these are, I would be curious what would be the usual next step for such a contribution? Would one need to write a Kubernetes enhancement proposal, or just shoot a pull request on which people would comment? So yeah, thank you very much for your time, and yeah, looking forward to hearing your input on this.
Before we go on to questions, Kirsten, thank you for a really nice presentation. That was just really nice. That was like way better than I expected.
Thank you.
Yep, very easy to understand.
So I can take a little bit of it because I spoke with you, Kirsten, on Slack. So I think it's a mixture of not wanting SIGO, but I think primarily not wanting something as large as PKCS11 as SIGO. Like I think the Mac stuff is like the Go version, like the Go compiler for Mac binds against like unstable Mac APIs. And so it like pretty quickly deprecates like Mac support as it goes on. Like they just drop support for like Mac OS from like 5 years ago, whereas like you can run it on like really old versions of Windows and Linux because it's not binding against sort of like unstable OS APIs. But I think it's a pretty large stretch for us to say that we're going to start taking PKCS 11 dependencies into core. Maybe it's like maybe if kubectl was its own repo and we could like segregate it, maybe. Now, have you thought of like so I don't think we want a PKCS 11 proxy because I don't think that gives us anything other than like a lot of heartache. Have you thought about what like a TLS certificate proxy would look like?
So on the very high level, this depends a little bit if this would be an internal API or an public API. I think I would prefer in the first iteration to have it more like a private API, since there would be really just one consumer for it. But what I could imagine is, for example, that you would spawn this process to the right, and then via standard input and standard output, use something like multi-line JSON protocol in order to communicate back and forward. So this is pretty similar to the way exec credentials currently work, with a huge exception that exec credentials are expected to send back either a token or a private key, so which are credentials that would live in the memory of your laptop and is not okay according to what we are contracted for. In this case, it would be pretty much like an exec credential, except you would send something like find key pair in one direction, and then you would have a JSON encoded response with something like a TLS certificate handle, and then the stub on the kubectl side would have to explode this into a proper interface, and then again it would call sign on the handle that it has received and something like this. But yeah, I wasn't sure if I should specify this at this moment, considering that if this is private API, then yeah, this can probably also be discovered as the implementation goes forward.
I don't know if I understand what you mean by private API. Like if kubectl is calling some external process in like any particular way, that's an API. It doesn't really matter if you can't like obviously see it. Like the exec plugin stuff is like a public API because there's an implicit contract between the binary you're calling and the kubectl binary, and we have to support it, right? So we call it an API and we version it and do all the things that we do with APIs.
So what I was referring to is that, for example, now with the exec credentials, I feel that's the most similar one. We're kind of making a certain guarantees to plugin developers that the exec credentials, yeah, has a proper API that is specified in a certain way and so on. And so plugin developers can develop that. And this makes a lot of sense. And it's even documented and things like that, right? So anybody can write an exec credentials plugin. Whereas if I feel at least that if there is really only one consumer for this TLS certificate proxy style protocol, then maybe it doesn't make sense for them to advertise an API that you then document, then you make stable and so on. Unless of course you think that this would be a good idea, in which case that's how we would do it.
I can see this being useful more broadly. You know, if I wanted to implement the TLS handshake with a key bound, I mean, I don't know if this makes sense, but with like a cloud KMS type thing or some other
Touch ID, Mac Touch ID.
Yeah, there you go.
That brings
So
me to
something that doesn't want to actually implement PKCS 11.
how does this work when you don't have a pin in the kubeconfig? Do you have to touch every time the kube control establishes a new connection?
In the current implementation, yes, you would have to type your PIN every single time. There are some implementations of PKCS11 which kind of cache the PIN between processes, but I would say that this is a little bit outside the scope of kube control.
So
on the pin thing, couldn't the pin part live to the right of the blue line beside TLS certificate proxy, right? Like like, I mean, I guess it depends on how you communicate with the process, but like if you can have like a, like, I don't know, maybe a socket so that way the other end can detect if the socket is messed with in some way. After the initial start, it could hold on to the pin in memory.
That's actually a really good suggestion. I have thought about it. So the process to the right could potentially, yeah, just start once and maybe stay in the background for a while, and kube control would spawn it only if necessary. This resembles very much the way PGP currently does it. It's had its own smart card daemon that is being, kept in the background for a while, and amongst other is in order to implement pin retention policies. So yeah, that sounds like a really good idea.
I think it also parallels the discussions we've had, well, first of all, with the KMS plugins on the API server, as well as the external signer on the API server that basically delegate whatever we can out of Kube core, make us make the fewest decisions and lock-ins, and then let that be implemented by the plugin.
Mm-hmm. And then probably the plugin could just receive the whole configuration block when it's being started at the beginning.
I think it's important to understand what requirements that you're trying to satisfy. It sounds like there's some compliance requirements, but I'm not sure if it was explicitly stated what those are in the issue. I haven't looked at it yet. So what are your requirements?
So on a very high level, we're basically just told to make kube control support the PKCS 11 standards. And we have two implementations that we need to two HSMs that we need to test whether this works with. And otherwise, we're pretty much told, yeah, do whatever is necessary to make this upstreamable.
So that doesn't, I'm not sure if that sounds like a requirement so much as a work item. Was there a specific compliance guideline that you needed to comply with? Or does some European compliance guidelines say you must use PKCS 11 for client authentication?
So we weren't quite given things at that high level of explanations, but my assumption is that the compliance were really much of physical security. So they want to be able to point where the credentials are being stored so that you can actually physically inspect if they has been extracted in any way or another. And then of course, the way that this requirement has been translated into software is use the PKCS 11 standard. That being said, it's not the only one, and my understanding is that it's not necessarily the best standard to talk with HSMs. It's just the one that we have been required to implement.
Yeah, I would be interested in understanding some higher level requirements that led to this solution. There's, I think, a common pattern of doing this on initial authentication and then requiring re-authentication periodically. Would it be sufficient to connect to an authentication service, do an initial login, and get a short-lived credential for to talk to the API server that lives outside of the lives outside of your YubiKey?
So I'm not quite sure to have understood your question. So what I wanted to highlight is that in the PKCS 11 standard, you have to specify to what HSM you're talking to, and you have to specify which certificate you want to use of that HSMs. Now, of course, there are several ways of discovering what the right certificate is. You can either address it numerically, or you could, for example, list all the certificates and then look at the subject. That would be another discovery mechanism.
So like when I log into GitHub, I only touch my YubiKey on initial login. And then I get a credential that's stored in my browser that I use to authenticate further requests to GitHub. Additionally, a common pattern is to require periodic re-authentication so that I have to do that flow maybe once every 24 hours.
So no, we were not given any specific requirements with respect to that, but I assume that the how should I say, from a user experience perspective, the flow that you just mentioned makes the most sense.
Mm-hmm. So I think there's some interaction with session resumption in TLS that makes the security properties of that model and this model very similar, because depending on the server configuration, even with a key, public private key stored in a TBM, you still end up with secrets that are able, that carry an identity, that live outside of the TBM.
Oh, that's something I didn't know of. Could you tell me more? Does kubectl actually store some SSL restart token somewhere?
If you connect to kubectl, if you connect to a server like Envoy or Nginx, which people are using as front proxies to the Kubernetes API, they can be configured to support TLS session resumption. I don't think Kube API server supports it today, but many common L7 proxies do support TLS session resumption.
Okay, but do I understand correctly that it's also up to kubectl to implement something for session resumption?
No, it is not. Kubectl, it's the Go TLS libraries. If there's a little cache in the TLS object or TLS config object that will automatically be filled with session tickets for use with resumption.
And this would be stored somewhere on the file system, right?
Memory, probably.
Mm-hmm.
We don't reuse sessions though on subsequent commands though, right?
That is true, but it's, I think the key point is that it's something that is about as easy to steal as a certificate that lives on disk, or a key that lives on disk. So ideally, if you want the property that you have to touch your YubiKey every time you want to authenticate as your identity, you need to be careful of secrets that carry the same identity and make sure that those are protected to the same level as your private key.
No, this is very valuable feedback. Thank you. So probably I would have to push this back and this would likely need to be reflected somewhere in documentation, like in case you want these guarantees, make sure to also do this or that to ensure that TLS resumption is disabled.
Yeah, no, I'm just brainstorming a little bit. I don't think it's a very common thing to have enabled, just because I think most people are not using L7 load balance or L7 proxies in front of their API servers, but something to consider. And I think that gets to the point as like, I think we need a really clear set of security requirements when we design a solution here.
We got a decent chunk of other stuff on the agenda.
Yeah, that's the same thing.
I was going to say, so I think, Kristen, you had asked for next step. Certainly, I think sort of like a crispness on the requirements, maybe in the form of like user stories, would help sort of understand exactly the problem that like your employer is requiring you to solve and how we can sort of best enable that. I would personally feel like this is large enough to require a KEP, and there's enough people that care that I think a KEP would give it enough time to have people give feedback. Like, I'm very conscious of the fact that only a small subset of the community can attend this meeting. So that would be my recommendation. Tim, Mike, David, anyone else have?
Yeah, I agree.
Definitely.
That sounds good.
Is there an issue to carry discussion forward before we send you off to write a full-on KEP?
There is already an issue open. It should be the agenda.
It looks closed. Should we reopen it?
Yeah, it's probably worth just reopening and we can keep using that one.
Sounds good.
All right, I'd like to move along to try and get through everything else we have. Christian, would you mind unsharing your screen? Thank you. So next up, we have two polls of note. Micah, do you want to talk about external token signing criteria?
Yeah, I think I think there's probably not a lot to talk about here. I got good feedback on what to update for graduation criteria, so I'll go ahead and update the KEP with the feedback. Unless anyone else has anything else they want to add now.
I was going to mention, I think my general takeaway from this KEP and sort of just the functionality is there's a certain set of failure modes that are basically present on an API that's sort of like a gRPC local thing for the master, right? And we're basically like the same thing that happened like with encryption at rest from an on-disk configuration to KMS. And this is, you know, like an on-disk encryption, on-disk signing to an external signing, is they have basically the same failure modes. Like it went from a basically unfailable process to a vague guarantee that this external thing will keep working. And I know we've been going back and forth a lot with KMS recently. And the nice thing is this is basically a brand new thing and it's alpha, like it will start at alpha. So probably what we come up with to solve problems on this is relatively applicable to KMS minus the caching stuff that QSOF has. So that's kind of the lens I look at it. And basically, I think all the problems I stated, we've already stated for KMS. It's just the same problem. That's all I got.
All right. Yes, anyone interested in that? It's linked from the agenda. Take a look. The next poll of note we have is the implementation for the external registry credential provider extraction.
I just wanted to go by and decided to add it here. I think the KEP was marked as implementable, although it is getting pretty late to, and before code freeze to review, but I thought I'd give it a shout out anyway.
Yeah, sounds good. Yeah, it was originally, we were targeting 118. This is looking like it might be a long tail for cloud provider extraction. So I will try and take a look at that today, but I agree that it's coming in pretty hot.
Did you have anything you want Nick any feedback for Nick or anything you want him to look at?
You better get some code reviews if he wants to make the, I guess, tomorrow deadline.
Okay.
And it's all red right now, so it has to stop being red.
Yeah, it definitely has to not be as red.
There he is.
Hey guys.
Yeah, so I'll try to make some time. Anyone else who's interested in this, if you can try and take a review task today, and we can sort of evaluate based on our reviews whether we think we can make it.
Cool, sounds good.
Right. Let's see. No. Yeah.
Am I the one breaking up, or is Tim either? He's like really loud.
I think it's Tim's.
Sorry. Can you hear me?
It's a little better now.
All right. Yeah. Do you want to talk about this issue?
Yep. So for 118, we had the KEP for the OIDC discovery of the service account issuer. We got that in. I forget who wrote the code and but we got immersed and everything's awesome. One of the things that I had sort of disagreed with on the KEP, but decided, I didn't want to lock the KEP on it, was the RBAC around it. So I'd made the PR to basically allow anyone who's authenticated to be able to see the discovery endpoints. And then I was discussing with Mike his concerns. So I mean, I think it comes down to like Mike, I know your concern is basically anyone can authenticate to GKE or the Gmail, which sounds kind of crazy to me. But I do understand that that is a reality for you guys. So I'm trying to think of how we can kind of move this forward, because to me, like, this kind of functionality should sort of be always available to be like most broadly usable, right? Like if you make it so that like people that are using a cluster can't rely on it being there, then you just can't rely on it being there, right? Like if it's sometimes there because you were given RBAC and sometimes not, right? Because it does require a cluster role binding to give it to you. And most people aren't supposed to be able to make cluster role bindings.
I guess, what is the point of bootstrap policy?
To be most, like, have the most usable thing from go, like,
is it to provide a like baseline? We need to make these controllers be able to do stuff that they need to do and give an initial administrator admin permission, or do we want to have like maintain curated roles? I guess fundamentally, I don't see why. I think there needs to be a strong reason to make choices for an administrator that are very difficult for them to turn off.
Sure. I mean, but we curate like we curate admin, edit, and view, and all sorts of other like.
This is true. That kind of leads to my question. So we have used it for both types of roles, and we have used it before for role bindings, and we've also tried to walk back some of the stuff we've done with role bindings. For us, I don't see, for speaking for GKE specifically, we have the same authentication stack as the rest of Google Cloud. Anybody can authenticate. We don't consider that a significant boundary to accessing Google APIs. We tend to use authorization for that. So this is particularly problematic for us, this proposal, because the issuer URL gives information on the name of the cluster. So while people can scan, we have very many GKE clusters that do use public endpoints, and this would allow scanners to not only discover that this is a Kubernetes cluster, but also that this is, so-and-so's Kubernetes cluster. So that's why it's problematic for us.
Now, like, my question to that is, have you guys considered walking back the anyone can authenticate to my cluster? I'm just going to say it's anyone, because anyone can get a Gmail. Like, that's kind of the point of Gmail. Like, I don't understand that reasoning, right? Because that's like it's just weird to me to say that anyone can.
Yeah, so it has been problematic before. It is challenging to make a change there. It's not clear how we would map sets of people to clusters. There's plenty of reasons why it's challenging to do this in retrospect. And like, this is potentially, I don't know, I want to make the argument that if we don't do this for like a GCS bucket. Why would we need to do this for Kubernetes, which has traditionally been suited to this model?
I would just add, as soon as you're making a decision about limiting access, that's an authorization decision. The fact that we generally have limited authenticators, I don't think is an argument for, in principle, like that we should use that as a baseline authorization decision.
No,
I don't think it's.
But like the whole like walking back that we did for system colon unauthenticated for the discovery stuff, right? That still means that today anyone can do discovery against your Kubernetes clusters, right? And if there's another proxy CV, all GKE clusters are vulnerable to it, right? So like a lot of the arguments that were used to make it so that we must only have authenticated discovery really fall apart when you say, well, anyone can authenticate, right? Because now you're at the point of like, oh, you must have like some kind of write access to this cluster to read discovery, right?
So,
like,
for that specific example, we are caching discovery information in the API server, and we serve it from cache, and we don't proxy it anymore.
No, I understand,
that was
but like
the solution to that problem that we had. Changes like this are very, very, very hard to walk back. And philosophically, I'm not sure that I agree with relying so heavily on authentication for this type of stuff. I think that it has benefit restricting authentication from defense in depth, but I would like our initial authorization that we set up for the users to be sane and to be minimal, such that we defer decisions to operators to make choices that suit their needs.
I mean, I don't think I really follow that though, because like at the end of the day, this kind of functionality is about discovery, right? Like discovery is supposed to be about I can build on top, right? So like if I'm going to build like an extension that allows you to have like nice, like simple service-to-service auth or something using service accounts, right? It's a kind of hard sell to say that, hey, you have to install my extension, but you also have to be cluster admin to do so, right? Because no one else has any permission to do it.
If a cluster admin hasn't decided to expose this information, do you think the cluster admin would want someone installing the extension you just described?
I mean, I don't really think I particularly care as a cluster admin if you can verify service account tokens. Like that seems okay, like, right? It's public data, you're verifying a piece of private data using a public key, right? Like I put this in the bucket of public data, right? Yes, the issuer URL could tell you something about the cluster, right? Like I put it in the same category as that we had, like, since David, you asked, like, you know, since we had the well-known endpoint in OpenShift, I put this in the same exact bucket as that.
I think it's less concerning. Go ahead, Tim. I've already talked.
Yeah, I just wanted to time box this because I don't think we're going to get this change in for 118. And I think it needs more discussion. And also, Jim has joined us from the policy working group, and so I want to make sure that he has time to discuss some of the issues on the agenda. So is it okay if we move on and then pick this conversation up either offline or next meeting?
I was going to make one thing. I had suggested that we could bind it to system service accounts to make it so that you had to have write access to the cluster in some way to actually get to it. I don't know if that helps, but it's
That's much more palatable. Let's discuss further.
All right, thanks. Yeah, Jim, why don't you take it away? You're muted.
There we go. Yes, so two different things to discuss, both working group projects. One is related to multi-tenancy. So the first document that Tim is just pulling up is a set of benchmarks that we, so multi-tenancy, of course, there's a lot of different work streams going on, including trying to define, what different constructs for providing multi-tenancy. But one of the topics, one of the questions we get often in the working group is, how do I know if my cluster is properly configured for multi-tenancy? So the intent here was really to start defining a set of tests, validation tests we could do, both behavioral as well as configuration checks. And that's what this is outlining. So we are collecting comments. We're also starting to implement some of these tests. The goal here is not just provide the tests and definitions. So each one of these links to some definition in a Git repo. But it also, we want to provide an automated test suite, which you can run on a cluster and, kind of try out different behaviors like accessing, either like network access across namespaces or even resource access, things like that, and validating what level of multi-tenancy a particular cluster or a set of configuration is trying to achieve. So that's this particular effort and work stream within the multi-tenancy working group. And how this will relate, there's other work streams, like there's the virtual clusters proposal from Alibaba that actually virtualizes part of the control plane itself. And then there's the hierarchical namespace controller, which Adrian and a few folks are working on, which helps manage configurations across namespaces. So all of those are, again, tools and means to implement multi-tenancy. The effort here was measuring and reporting some set of validation on multi-tenancy levels. So please, I think this was just more making folks aware of this effort. So if there's any comments, feedback, would love to collect that. And what we were planning on doing next is starting to automate some of these tests and also further refine and define like the categories as well as the levels that we have laid out. So I know we're limited on time today, so I'll stop there on this. And if folks want to take a look offline, happy to do a deeper dive in a subsequent session. But Tim, was there anything else you think we should cover now, or?
Yeah. So first of all, I said you were joining from the policy working group, but I think it's the multi-tenancy working group that's driving this work, right?
That's correct. This work is from the multi-tenancy. The next item on the agenda was from the policy working group.
Oh, okay. That's why I was confused. So the one question I had on this, I think I brought up in the email, was how do you see this relating to the CIS benchmarks, which there seems to be a lot of overlap between the two of them, and I'm wondering if it makes more sense to think of this as a kind of an extension or another layer on top of the CIS benchmarks as opposed to a totally separate project.
Right. Yeah, so the CIS benchmarks, from our understanding and our usage of that, it seemed more focused towards, of course, making sure like the security best practices are followed for configuration. So there's a number of different configuration, types of recommendations, right? So, but they didn't seem to reflect, again, whether even following all the CIS benchmarks, there's no guarantee or there's no multi-tenancy, whether you've achieved it or not, is sort of left loose, right? So what our focus here was to just, sort of pick the tests which would try and measure multi-tenancy and verify multi-tenancy only. And we didn't want this to be something which are just security best practices. Now, of course, there are things like a CIS benchmark, like, okay, you must enable RBAC. Yes, of course, and that would get validated, of course, as we run some of these basic tests across namespaces. So We didn't see, and maybe there is, maybe it's worth a closer look and understanding if there is a clean way of saying that, okay, if there's some level of CIS benchmarks where we could require that as a minimum starting point, then certainly that would make sense. And one possibility is there are some tools out there which we can run to also, or it's possible to write those tests as well and validate certain configurations have been provided.
Yeah, so I know that I think the CIS benchmarks get into some things like pods or containers should run as non-root,
Right.
and you have network policy enabled. And so the pieces get more into the realm of not just general cluster configuration, but also the workloads that you're running.
Yes. Yeah, the one difference here is we didn't want to, for certain things, we didn't want to mandate configuration. And this was an interesting discussion point because for something like pod security policies versus, achieving the same through other mechanisms, we wanted to allow that flexibility, right? To say if you're configuring your pod as non-root, even if that's manual, we can validate that and report on that. So we weren't requiring necessarily that PSPs have to be set up, but it was more, checking that the end result, of course, is that the pod has that correct configuration. So there were nuances like that, which we were discussing in the same discussion we had with network policies, because so network policies are great at layer 4 segmentation, but you could, in some cases, we've seen that teams are now doing layer 7 policies, like perhaps with service mesh or similar. So that was another, where we didn't want to necessarily require that you have to have network policies configured, but it was more checking if there was segmentation across or isolation of networks and ingress and egress traffic within these workloads.
Yeah, that makes sense. The other thing I want to mention with regards to the CIS benchmarks is if you haven't configured the cluster securely, then you can't really have safe multi-tenancy in the first place. And so
yes,
I do think it kind of makes sense to sort of start with some of those.
Okay. Yeah. So what we can do is we can go through and at least maybe identify the CIS benchmarks which would be applicable, and ones which we perhaps want to take a slightly different stance on. We can even identify those and explain why maybe there's some more flexibility required than the currently, I guess, documented CIS benchmark.
Yeah, I do remember some problems with the CIS benchmark related to it being so strict that it was extremely difficult to use such a cluster. And I also remember that it was very difficult to get those things changed. Now, I guess in this case, we would probably be able to change recommendations, but I don't think I would just blindly take a CIS benchmark.
Yeah. I think a lot of those problems were in some of the earlier versions of the CIS benchmarks, and I think they've resolved a lot of those issues in the latest version. And also introduced an idea of like multiple levels. So there's sort of like the base recommendations and then the increasing levels from there. Jim, have you reached out to anyone who's worked directly on the CIS benchmarks project?
No, I have not.
I can get you, I can help find some contacts there. I think it would be useful to meet and get their perspective on how this would fit in.
Yeah, that would be excellent. Thank you. I'll reach out after we can do that. Okay. So real quick, just the other effort that I wanted to highlight was now this is with the policy working group. So there, of course, there's again lots of different work streams. One of the things we were discussing is so we're seeing there's more and more different ways of implementing and managing policies. some some tools like OPA, Gatekeeper, and Kyverno, they're doing admission control level policies. Falco is doing runtime policies. There's Krail, which is doing also some policies which are mostly admission control, but also other considerations. So the idea that we were discussing and what seemed like everybody in the working group agreed to was, and thought would be a good idea moving forward, is if at least there's a common way to report policy violations, independent of which tool is used to do the checks, the audits, etc. So that's what this CRD proposal is, to have a policy violation, which different tools, so either through adapters or natively tools can support. And the benefit there, of course, is a cluster admin or users can see violations in a consistent manner and can also do other reporting and visibility based on that. So that was the intent of this proposal, and I think related to that, one other question that had come up is we don't have a place for some of these type of proposals or work streams in the policy working group. So I think there was a Git issue that we had raised to try and and I'm not sure what the exact process is, but to get and I think what was recommended was this should be under the SIG, the Kubernetes SIG's repo. And in multi-tenancy, we already have a folder where we put our working proposals, things like that. But we don't have a Git repo for the policy working group.
Yeah, I think that that's going to have to be a bigger discussion, and we're out of time for that.
Okay.
Maybe we can follow up or next week or 2 weeks. Quick question on the policy violation, CRD. Is that for a more of like a dry run in a situation where I want to see, like, here's my policy, show me what's already running and violates it? Or would that be for, I have a policy that's being enforced on the cluster and someone submits a new, say a new pod that violates the policy, it gets rejected, and now I want to surface that as a violation?
Right, so we were envisioning this more for existing resources or reporting violations. So reporting violations, I guess on any configurations, any resources which already exist in the cluster. If something is rejected and different policy tools have different, I guess, settings, like one of the things Kyverno supports is the ability to either block or just to audit, in which case it will generate a violation. So based on that setting, then an admin could decide whether they want to outright just block a resource or they want to allow it but report a violation. And the other use case would be for any existing resources before that policy was put into place. And then, like you mentioned, the dry run. So if I have a cluster, I just want to run a scan and see what violations exist. That would be the third use case.
Okay. Well, we're out of time, but I'll take a look at the documents you linked, and I encourage anyone else who's interested to do the same.
Yeah, I would love to get more comments, feedback, and thoughts on the direction.
All right. Thanks for joining today.
Sure. Thank you.
Thanks, everyone.
Thank you.
Take care. Bye.